So before we get into today's lesson, I will let you start with a little warm-up problem. Okay, you can try this, pause the video, give it a shot. I want you to differentiate the function e to the power of log root x minus 3 times the inverse cosine of ln x to the fifth plus the inverse secant of tan root x squared, or tan squared root x. And here's what the answer should be. Okay, you do not have to simplify your answer. Hopefully you got that. Now, on to today's lesson. So we've finished up differential calculus, finding derivatives or working with derivatives and applications of derivatives. Now we are going to look at something called integral calculus. All right, we're going to look at antiderivatives for starters. So up to this point, our study of calculus, we have been concerned primarily with the problem, given a function, find its derivative. Today, we're going to look at the opposite, or the inverse. Given the derivative, find the original function. And there's many problems or applications of calculus that involve this inverse problem. So to differentiate means to find the derivative. To anti-differentiate, all right? So for every differentiation rule, there is an anti-differentiation rule. We're going to look at just some general antiderivatives today. So for example, suppose we are given the following derivatives: f prime x equals 2, g prime x equals 3x squared, and h prime t equals 4t. We want to figure out what f of x would be, okay? What g of x would be, and what h of x would be. Okay, so for these ones, these simple ones, it's probably not too difficult to figure out, well, what would you have to take the derivative of to get 2 for an answer? So you're kind of working this way. Typically, we would give this given the function, and we'd find the derivative. The answer to that is 2x. Okay, the derivative of 2x would be 2. What would I have to differentiate to get 3x squared? Well, the answer to that one would be x cubed. And finally, here I would end up with a 2t squared. Okay, so check this out. The derivative of 2x would be 2. The derivative of x cubed would be 3x squared. The derivative of 2t squared would be 4t. All right, but you may not understand how I was going from the black to the red. All right, we know how to go from this way, the red to the black, okay, given the function, find the derivative, but we kind of have to flip our brain in reverse when going from the derivative to the original function. And when we're doing a general antiderivative, it's important to write plus c after you find the antiderivative, because there could be a constant back here. A general antiderivative actually represents a family of curves, and I'll show you what I mean by that in a minute. So the operation of determining the original function from its derivative is the inverse operation of differentiation, and we call it antidifferentiation. Here's the definition. A function capital F is called an antiderivative of little f on an interval I if capital F prime x equals little f of x for all x in the interval. So here's some notation you might see, like if they give you f prime, if you start with f prime x, then your antiderivative we would call f of x, and I'd call that 3x. But if you start with little f of x, the notation they use is capital F of x. And the antiderivative of -5 would be -5x. You can always double check your work, okay? If f of x equals 3x, f prime x would be 3. That's what we're used to doing, finding derivatives. If f of x equals -5x, f prime x would be -5. We are used to doing this. Okay, so the inverse operation of differentiation is anti-differentiation. So going from f of x to f prime x is differentiation. Going from f prime x to f of x is anti-differentiation. And here's what I meant by it represents a family of curves. Okay, let's look. Here's an example. The derivative of, let's say we have f of x equal to 1/2 x squared. It might be easier to think of it like that. The derivative of that would be 2 times 1/2 is 1, x to the 2 minus 1 would be 1, x to the first. What about this? What if I did the derivative of this? I'll do that in red, because I always do derivatives in red. Well, the derivative of 1/2 x squared would be x. The derivative of plus 2 would be 0. So here's what I was saying. It represents a family of curves. There could be a constant back here. The derivative of x squared over 2 is x, but the derivative of x squared over 2 plus 2 is also x. All right? And I'll change this to red just to make it look sharp. Maybe I won't. All right. So here are a bunch of different curves. Y equals x cubed over 3 plus 3, x cubed over 3 plus 2, x cubed over 3 plus 1. If I take the derivative of any of those curves, I would get the same thing. So look, it doesn't matter if I take the derivative of this one, the derivative of x cubed over 3, or 1/3 x cubed, would be x squared. Okay, 3 times 1/3 is 3 over 3, which is 1. X to the 3 minus 1 would give me 2, and the derivative of the constant plus 3 would be 0. The derivative of the constant 2 would be 0. It doesn't matter what the constant is. So this antiderivative actually represents a family of curves. It says notice the slopes of the tangents on each curve at the same x coordinates. If I drew a tangent here, 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 those tangent lines all have the same slope. And it wouldn't matter where I drew them, it's the same, as long as it's at the same x value, the slope of the tangent line would be the same. So first thing, we've kind of done this one a few times. If it's a constant, given the function, given the, this represents the derivative, you want to find the original function. The antiderivative of f of x is capital F of x, and it would equal 17x. The rule is simply this. If f of x equals k, where k is a constant, capital F of x, the antiderivative, is kx plus c. So notice I forgot to write my plus c here. Okay, remember, don't forget the plus c. It's a general antiderivative. So another example of that, and I think most people prefer this method. If they give you f prime x equal to -2, then f of x, the antiderivative, would be -2x plus c. Okay, f prime x equals -2, f of x equals -2x plus c. All right, what about the power rule? Okay, what's the antiderivative of 6x squared? So think about what you would have to do. Think about, like, if we have the power rule. Let's look at something like f of x equals 3x to the 4th. The derivative of that would be I multiply 4 by 3, 12, x to the, and then I subtract 1 from the original exponent. 4 minus 1 would give me 3. So think about, like, flip your brain completely in reverse. Instead of subtracting 1, what's the opposite of subtracting 1? You would add 1. So I'm going to add 1 to the original exponent. So this would become x cubed. And then instead of multiplying the coefficient by that new exponent, I'm going to divide. Okay, the opposite of multiplying would be dividing. So I take the 6 and I divide it by 3. Don't forget your plus c. And I would simplify this. 6 over 3 is 2, x cubed plus c. Double check your work. If f of x equals 2x cubed, f prime x, 3 times 2 is 6, x to the 3 minus 1, 2. So you add 1 to the original exponent and then divide by that new exponent. Don't forget to write plus c. Here it is. If f of x equals k times x to the power of n, capital F prime x, the antiderivative is k divided by n plus 1 times x to the power of n plus 1 plus c. So I'm adding 1 to the exponent and dividing by that new exponent. Here's a couple of examples. I like to add 1 first, so 7 becomes 8, and then I divide by that new exponent. Don't forget your plus c. Simplifying, I would get 4/8 to reduce to 1/2 x to the 8th plus c. Check your answer if you want. 8 times 1/2 is 4, x to the 8 minus 1, 7. The derivative of a constant c would be 0. All right, I'm going to add 1. So negative 1/4 plus 4/4 gives me 3/4. So it'd be x to the 3/4. I'm going to take that 23 and I'm going to divide it by 3/4. If you're wondering what 23 divided by 3/4 is, remember how to divide fractions. It's 23 times 4/3. 23 times 4 would be 92. 1 times 3 is 3. I got 92 over 3. Doesn't reduce. X to the 3/4. Don't forget your plus c. There is your antiderivative. So far we've learned 2 rules. We've learned how to undo the power rule, and we've learned how to anti-differentiate a constant. Just like when differentiating, don't do anything until we get everything written like a power function. So in this particular case, it's this term that needs to be cleaned up. It'll be 2x to the negative 2. And it wants me to anti-differentiate. I'm doing the antiderivative. So for all of these terms, don't forget your notation. If you're given a little f of x, the antiderivative is capital F of x. If they tell you f prime x to begin with, well, then you can write little f of x. But add 1 to the exponent, divide by that new exponent. Add 1 to the exponent, so 2x to the 5th, divide by that new exponent. This would become negative 3x to the 4th divided by 4. This would become 2x to the negative 1. You add 1 to negative 2. Negative 2 plus 1 gives you negative 1. Divide by that new exponent. Add 1 to the negative 3 gives you negative 2. Divide by that new exponent. And the derivative of constant is just antiderivative of a constant, is 5x. Don't forget your plus c. Now I'll just clean this up. Capital F of x is going to equal x to the 6th over 6th, or 1/6 x to the 6th, if you like. Negative 2/5 x to the 5th, minus 3/4 x to the 4th. This would give me negative 2, 2 divided by 1. And instead of writing x to the negative 1, I'll call it negative 2 over x. This would give me negative 5 over 2, and the x to the negative 2 is going to go down here. Plus 5x plus c. There is my answer. Okay, move on to this example. Clean it up. F of x is going to equal 3x to the 1/2 minus 2 over 5, and I'm just sending the x to the 4th to the top to become an x to the negative 4. Okay, a lot of people want to bring the 5 up as well. Don't bother bringing the 5 up, just the x to the 4th goes to the top. This would be x to the 7/5. This would be, think about this, x to the 1/2 divided by x squared. excuse me, subtract the exponents. 1/2 minus 4 over 2. 2 over 1 would be 4 over 2. It gives you negative 3 over 2. So this would actually be 6x to the negative 3 over 2. So I just divided that root x, or x to the 1/2, by x squared. And I simplified it. Plus e squared. Remember, that's a constant. That's Euler's number. All right? So now I can do the antiderivative. The antiderivative of little f of x is capital F of x. I'm going to add 1 to the exponent. 1/2 plus 1 gives me 3 over 2. And now I divide by 3 over 2. Minus 2/5 x to the negative 4 plus 1 is negative 3. I'm going to divide that by negative 3. This would become x to the 7 over 5 plus 1 plus 5 over 5 is 12 over 5. And I'm going to divide by 12 over 5. This would become negative 6x to the negative 3 over 2 plus 2 over 2 plus 1 would give me negative 1 over 2. I divide by negative 1 over 2. Remember, this is a constant, and the antiderivative of a constant would be e squared x plus c. Now it's just a matter of cleaning this up. Capital of that f of x equals, what's 3 divided by 3 over 2? Remember, 3 divided by 3 over 2 really means 3 times 2/3. That would just give you 2, x to the 3 over 2. Negative 2/5 divided by negative 3 would be like multiplying by negative 1/3. That would give you positive 2/15. And the x to the negative 3, well, that'll go down with the 15. 1 divided by 12 over 5 is like saying 1 times 5 over 12. Gives you 5 over 12, x to the 12/5. Negative 6 divided by negative 1/2, that's like saying negative 6 times negative 2, gives you positive 12. And I'll take that x to the negative 1/2, and I'll send it to the bottom and call it x to the 1/2, or root x, plus e squared x plus c. That is your final answer. And you can always check, if you do the derivative of this, 3 over 2 times 2 gives you 3x to the 1/2. Boom. Okay, that's what I started with. And you can do it for each of those terms. So we've got constants and powers. That's enough for now, but this is something that you will need to know. Okay, so I'd recommend printing that page out if you want. Here are the functions. So we've done this one and this one. Tomorrow's video will look at kind of a mix of the rest of them. We'll focus kind of mainly on this one, and then scatter a few of those ones in there. But you have to know these. So if the function is just a constant, the antiderivative is ax plus c. All right. If the antiderivative is a power function, ax to the power of n, where n is not a negative 1, we add 1 to the exponent, divide by that new exponent. Don't forget the plus c. Got to know those. All right. Just like your derivative rules, you need to know your table of general antiderivatives. You can try those questions on page 408.